What's going on, everybody? Welcome to another Zabbix video. Wrong intro. The correct intro is ladies and gentlemen, boys and girls, we have a special day today, and that is when Zabbix product got quite seriously better. And today the use case which will indicate how to use special functionality in Zabbix is to monitor Windows laptop or Windows laptop practically, and we will do the process monitoring to identify which process in long term, more like a service, takes the most juice out of the CPU. So that will be the use case. The company behind the scene, the company behind this, what makes these dreams happen is Monzphere, which just recently in April 2025 released a module available publicly, which really solves long waiting functionality and now make some new things possible in Zabbix 7.0 or 7.2. And now, more about the company by the end of this video. But right now, on the use case. So what we will do today is monitor processes on the Windows computer and find out which process in a long term takes most of the CPU, and all that thing will be kind of like animated in a very like on the fly manner, where we will find out which process is hot right now, or which process is hot in the last 5 minutes or in the last 1 hour, maybe even like yesterday. We can compare yesterday with the today. So let's create a template and create a template. This will be called CPU processes. Inside this template, actually I will apply this template immediately on a host object, CPU processes, update, and now inside the template we will create a collector item, and this collector item will be very much based on the VMI query. What we will do is we will run a VMI query to find, to extract, to pick up the counters of different processes. So what this is not doing, it is not extracting any percentage. If you are looking forward to see which process takes 1% of the CPU usage or 10% of CPU usage, that's not what this solution is doing. It is looking on the counters, and the process who spins the counter with the fastest speed, like in the car you have like a speedometer and you have a distance meter which tells like how many kilometers or miles the car has been driven so far. So the same story happens with the counters, and what this query is doing, it is looking for the how many CPU spends on the CPU, and it is these metrics are classified in 2 categories: kernel time and user time. For those who are a little bit familiar with the Linux system, when we run the top command, there is also like a column over here, time, which is the same thing. Like it tells like this very particular process spend like 16 seconds and 156 minutes. Since the service is in the running state, it spent quite some like it asked CPU to help to calculate some things, and this is the like total time spent since the service is running. So we will do the same, and the solution is based very much on this VMI query. So this is the item which will report back a textual information. Let's put it a text. Actually, I prefer here a log. And the time budget to get the data done, it is 1 second. Every 1 minute, it will completely read absolutely every single process from the Windows computer. Okay, add. Now, since there can be possibility that a lot of processes runs with the same executable, for example, Google Chrome, when we open one tab, two tabs, three tabs, inside the process list, it will be always called chrome.exe. Because of this reason, like, we need to extract unique processes like from the process list, like unique executables. To do so, we create a dependent item. This will be called name, and the pre-processing to use for this thing is using JavaScript. And so what it does, this value, it is reporting back data, those two columns, kernel time and user time. And now it's looking on the name field and it's extracting unique processes. I will show that in a moment, how it looks as a source and how it looks in the output. So this will be the first step to extract unique processes, and it will produce JSON in the outcome. And with my experience, with my Zabbix experience, sometimes JSON needs to be sorted, and it is required. Let's put this pre-processing step here. In a long run, we will use this other pre-processing step, like discard unchanged with heartbeat. So what it means, like, if the amount of processes in the Windows computer does not change, then don't bother Zabbix low-level discovery. So otherwise, if we execute this item every 1 minute, I mean the master item every 1 minute, it can give too much overload. If you have 100 Windows clients and every 1 minute we collect the process list, it will overload the LLD rule. And what we want to do is we want to protect the Zabbix LLD by introducing this throttling. And for the throttling, it works very perfectly if we always like sort the JSON, and that's the reason why I have this second pre-processing step. Okay, now this is everything for that extracting unique process names, and it will have that data after 1 minute. I will show in a moment, but another thing is, okay, let's actually start to show the outcome inside the host level when we look what kind of data is coming, and the answer is this. Like, we have counters, kernel mode time, this is a counter, and if this like CSRSS exe spending more resources, this number is going up. And the way how we will measure which process consumes most of the CPU, we will always look on the counters. If the number is going up, that's bad, it's consuming the battery of your laptop, or it's just consuming CPU power. And here we see two metrics: kernel mode time, this is one counter, and user mode time, this is another counter, and then like the name in the middle. And now the next dependent item, it will do the total aggregation of both counters together. To do so, we will create another dependent item, and I will call it total. And this will have another JavaScript pre-processing step, which is this. And what it practically does, it iterates through the array, and it is introducing the third column, which is practically doing a sum of kernel mode time and user mode time, and it will actually drop these columns and not use in a later sense, because it's too many items. So it will do the aggregation right now, and then no other reference to the individual one. Okay, so this will also be the log, and that is everything so far. Add. Now we have 3 items. I will show the total in the moment, I hope so. And now the unique names, while it's loading, let's go back one step here. Closing this up and going at the host level, I will open in a new tab, items, and the unique names, like what kind of unique processes is detected inside the Windows workstation or laptop. If we open, and now the JSON is very small, we see only the names of the processes. And this will be like the base of the low-level discovery. When it finds something new, it will immediately maintain this LLD cycle and generate new items. And if we have some trigger, then generate new triggers. And if the process goes away, it will leave the item just in case you decide to use the same process like tomorrow and so on. And eventually it can generate like thousands of items if the workstation is using a lot of unique programs, then the host will have a lot of items. But all of the items always will kind of look inside the master item, and if there is nothing new happening, then it will kind of reset the usage to the 0, just to satisfy the graphs and tell that this process is not running at this moment. Okay, that is the base for the LLD rule. Now we need to create the LLD rule, and to do so we have this name field, and we will click here and create dependent discovery rule. I will call exe, like executable, and here delete lost resources. It would be, this is a kind of exclusive functionality. It was not, it is quite fresh. And here we want to use never. Like if something gets discovered, we don't want Zabbix to delete that item. Just in case we want to look back if the user used that executable in a heavy way, like a month ago. So we don't want to delete the resources. And maybe here as well disable lost resources never. For this use case, when we want to monitor the processes on the workstation, we would use never here. From my point of view, that works the best. Now the mapping here, hashtag name will be the base variable, and inside here we will map with this name. Why the name? Because the name of the process is here, and this is used for the input for the LLD rule. We are mapping and introducing another low-level discovery macro, add. And now finally some item prototypes which will start to measure these counters, how much time each process spends on the ask CPU for help. To do so, it is dependent item. We will select the master item. So this is the raw data collector, which is every minute it is capturing quite a lot of textual data. The name is figuring out the uniqueness when a process disappears or a new process arrives. It will maintain the items and triggers and create new if necessary. And the total is the base input for to measure how much time it spends. Now the item key, it will be called CPU time. It is a self form item key, and inside the square brackets we are putting the name field, and here hashtag name and column CPU time. And again, this is not a percentage, this is how many seconds or milliseconds or nanoseconds CPU spends on that process. Okay, now the magical pre-processing step. We need to use JSON path and extract some stuff. And this is the logical thing. Let's go here back, opening what is the stuff inside the total. The total holds only two dimensions. One is the name, and the other is what is the total CPU time. And here is the field name, and inside the JSON path we have the same field, CPU time. And since the Google Chrome or Firefox or some other web browsers, they usually keep one executable for every single tab. That's the reason why we want to use the function sum, which will, at first, this item, this is blindly summing together. Here we see SV host, and same story is for the Google Chrome. If we have a lot of tabs, this JSON will have a lot of instances with the same executable, and then we have the counter. And yeah, that's the reason why this is doing this is necessary like that. And now since the way how the LLD role works, the way how dependent item works is every time the master item receives new value, dependent item will read the master item. And if we open a web browser, Firefox, and then we close, then it eventually there will be no web browser in your computer, and we really need to use this custom on fail and tell how to deal with the situation when the process goes away. And what we will do is we will really blindly reset the value to 0, the counter, nothing happens. What else? Dealing with the counters, to extract what's the damage, how much time CPU spent on this process. And the simple change is the answer. Since the counter is increasing all the time, this will guarantee the absolute maximum precision, because the counters don't lie. You will have I don't know, the precision will be up to the top. If we need to measure what kind of process needs more CPU, is it Notepad++ or Zabbix agent, this whole solution will give the answer with a very high precision, because counter is still a very raw thing inside the operating system. If people ask for percentage, that's some sort of calculation, some formula underneath the hood, but we can trust the counters much more. Okay, so simple change will produce the delta. It will read the counter right now, it will read the counter 1 minute later, and now we have the damage, how much time CPU spends. And we need to actually multiply this number with some with this decimal number. I asked the internet what is the raw, what is the it's producing very big numbers, and this will produce decimal number in the output. And to replicate the same style as we see in the Linux system, we have the minutes, we have the seconds, we have the milliseconds, we have the minutes. Now this will be measured as exactly like a second. Okay, that's everything here. Numeric CPU time. Okay, add. So the first item prototype is here, and it would almost let's I will create another aggregation and then show the outcome. So this is the item prototype, which is kind of master to extract the damage, how much CPU is eaten by a process. And now, since this is extracting every 1 minute, maybe we are interested in different aggregation, in last 1 hour, in the yesterday. And to do so, I will copy the item key. This is the item key, and create another thing, which is calculated item. and inside the formula field put this thing and use like a function sum, and after the comma it will be like 1 hour. And okay, and so it will kind of look back every 1 hour and start to provide long-term statistics to understand, was it a very spike moment when like antivirus started to scan something, or Windows updates is really started to kick in. So for that reason we can look back in a context of one last hour, but we will still calculate every 1 minute. Okay, so here I will call it last 1 hour, and inside the square brackets we will put it this guy, which is the name of the process. And now here we will call it we will call it name and last 1 hour. Okay, and this is also measured in seconds. And the pre-processing is not required because it will, the raw data is counter, and not the counter, this is like a bunch of deltas going on, like, and that's the reason why we are doing the total sum. Okay, now this looks good enough, and add. Okay, sum 2 times / to indicate the current host object, and then the item key. This is the template, actually. This is the template. Add. Okay. Now the fancy part, like this widget, which comes from almost, I want to say, sponsored from the Monzphere, which really is practical. By practical, I mean I personally like the tables which do the sorting on the fly and always highlight the biggest value on the top. That's my priority. If we can deliver something which puts the biggest number on the top, then I'm super happy. And now I will create at the template level a dashboard, create dashboard, and this will be called summary. And let's put the default refresh interval. And now this module, let's put like a widget, and the module is called ECharts Widget. I will show how to install it at the end of this video. Right now, let's see like if it even is appealing to you. And my one of the favorites is this horizontal bar chart. And what we will do is we will write this exe, and since the processes usually end with the exe, and then there is a colon, and then after that it will be like CPU time. Okay, looks correct so far. Add, and that is the widget. And let's call it like CPU usage. Add, and copy this widget and put it over here. Click, and we will call this last 1 hour. Okay, and this metric will be called again, it will target exe and target last 1 hour because I named the item that way. Okay, apply, and this is template level dashboard. Let's save it and now see if it even works. So here is the host object which with a linked template. If we visit the dashboards, and voila, I did not fail, at least to some extent. So what it says, like the chrome.exe is spending like 4 seconds of CPU time, and this was done in a in a time frame of 1 minute. And I know, like right now, I have a laptop near side by side with me, and it's playing a YouTube audio, a YouTube video, and playing audio is spending like 4 seconds of CPU time per 1 minute. This widget is not working right now. Maybe, probably I made some mistakes, and let's troubleshoot that right away. Click and item prototype, and last 1 hour is the item name. Last 1 hour, and inside, like, let's copy this guy to the clipboard. Copy, discovery list, dashboard, click, and open this guy. Last 1 hour, where is the mistake? I'm not sure. So let's try again. Star and star exe colon last 1 hour, like this. Click, and that is everything. Apply. Maybe this time it will work better. Hosts and dashboard. Okay, welcome to the troubleshooting session. If the items are generated, let's check. So here we have CPU time, and okay, yeah, it looks like the root reason is the items are not yet generated. Okay, while it's loading, so since the LLD rule, let's check if I did not left the discard unchanged in the name here. Click, and yeah, this is the reason why it was not generated. I was excited to this is how it should look in production, but for the sake of demonstration, since the process list is not changing, it is not generating my other calculated items. So for the sake of demonstration, I will remove that pre-processing step. While it's running, I will show the other very useful widget, which is the LLD list. The useful is not the correct word. It's like it's crazy good. That would be my statement. And here the widget which we target is LLD table, and here the underlying code, actually the implementation, how to target the items, it is interesting, exciting, and if you are a coder, it is even more exciting, like how to get the job done. And I will reveal that what the underlying code is doing, it is looking for like item names which contain these two symbols, the colon and a space. And what happens next is it will divide this item name into parts, one what is on the left side and the other what is on the right side. And yeah, based on that, it will aggregate and figure out how many items end with this pattern, last 1 hour, and how many items end with the pattern CPU time. So if the item prototype does not contain two symbols, nothing will work. It's absolutely mandatory. Also, for my taste, if you want to reproduce the same style of that widget I showed a minute ago, it's absolutely mandatory to put this LLD macro at the beginning of the item name. So it's very mandatory. The item name will start with the curly parenthesis open hashtag, and no matter what is the name, it must be followed by colon, space, and then this CPU time. Why it matters? It matters for the simplicity, because here inside the dashboard we see only the name of the process. We don't see the we don't see this CPU time, because the underlying script is erasing everything which is here. So now it looks very beautiful, very minimal. There is no chrome.exe CPU time. For every executable, it would be a disaster in a way, like I love this simplicity a lot. Like it does not contain those full item name, only the executable. Okay, where was I? LLD table. So it's the same story for the LLD table. We absolutely all the item names must contain the colon and space, like this. And additionally to that, I can put like exe, and on the left side exe there will be something, and on the right side there will be also something. And this is like everything. Click, and now what it will do, it will magically figure out like what kind of items are registered in the prototype. Just because I'm targeting this colon space, it will figure out there is CPU time and last 1 hour. So let's do C and statistics and add, and that's it. Let's put it like this. Oh my, okay, click, let's put a little bit room. So CPU usage, last 1 hour, and overall statistics, save. Okay, and it's a template level dashboard now, monitoring hosts, and if we visit it, and it works. I did not fail. That's awesome. So now we see these two widgets is this is real time. Which process in the computer consumes most of the stuff right now in the last 1 minute, and this is a little bit like more looking back in the last 60 minutes. So we see like the Google Chrome is dominating, and also the agent is spending something like because I'm collecting the data, but I see really the context while comparing agent with the Google Chrome. Like agent is consuming less. By the way, like this executable VMI PRVSE, like VMI, this is actually very related with what we are doing right now. We are asking VMI registry to give the statistics about processes. So if you think like what is this process, the answer is like it's very required for the task to generate statistics about what is happening. So this LLD table, it's there, and it offers sorting on the fly. If you are interested like which process consumes this CPU right now, we do 1 click. If we want to see what last hour statistics, we do 1 click, and here is the leader. I will show one example how to generate for the yesterday. So we would go to the template, go to the item prototypes, visit the process. This is the calculated item. Yeah, we will clone and call it something like yesterday. And this one as well, like yesterday. And to calculate yesterday with the as minimal CPU usage as possible, we can use the trick of scheduled item, like just tell, let's calculate at the midnight when the hour is 0, when the minute is something like 0, and when there is like, I don't know, 9 seconds pass the midnight, then let's look back and I'll calculate like 1 day of those deltas, which is extracted from the counters. Yeah, and it's as simple as that. And since I respect the same pattern, like this column will automatically appear in the table, which is like super excellent. Yeah, add. Okay, yesterday, and just another example like today so far. Today so far we can do clone, and I can call it like today and today, and to calculate today so far we can use I don't know the wording, but we can use this very syntax which stands for the yesterday right now, And to get today so far, what we will do is we will add 1 day. So this is the time frame, how much we want to gather the samples, and now divided by d, it kind of looks for a day which is available with the full 24 hours, and this out from the box resolves to the yesterday. That's the reason why we need to add 1 more day. And now to set like the we will gather the statistics every 1 minute. This is very aggressive, but yeah, we can set it later in a different way. And this is everything. So this will be a column which tells like how many CPU cycles the process has been spent today. Add, and we have another column. And 1 minute later, it will execute the LLD rule and show the outcome. Okay, while this is loading, I will show how to install this awesome module from the Monzphere. And to install the module, we have the SSH session, we have the front-end server. If we look on the packages and search for Zabbix, the front-end server is the one with the Zabbix web package. Inside this server, we have directory user share Zabbix modules, and inside this directory it should be empty out from the box. And to install the module, what we need to do is copy the link from the video description. It will resolve to this zip package. So wget and paste and download this zip archive. And so now there is this zip 29a. You will have exactly the same name, and then like unzip 29, and it's almost done. We can remove the package. And by the way, I was so how to say, when this module was released, I was kind of hysterical. I downloaded it. I uploaded to the Dropbox, to my personal Dropbox, just in case if it is removed from the internet, because it's too useful to lost the solution. And I suggested you to do the same, like keep this thing somewhere as a backup. So because this is very useful for the 7.0 Zabbix LTS. And the last step is go to the Zabbix and go here, General, Modules, and click the Scan Directory. And it will have like this picture, like disabled Monzphere, ECharts Widget disabled. And what we need to do is click Enable, and that's done. The module is installed and accessible inside your Zabbix instance. You can use it at global dashboards, or we can use it at template dashboards. Okay, now the outcome of that LLD table. The outcome is this. So we made one separate item for the yesterday, since I just made this template a minute ago. There is no stats for the yesterday, but for today, it already shows like how much time has been spent for this today. Okay, that's almost everything. I want to highlight my love on this decision that what I really like about this widget is it is the leader process is kind of taking the full width of this widget. So what I would try to say, like, the widget does not target processes which consume 100% CPU usage, and it's I like this a lot because it allows us to learn about the operating system. For example, so far I have learned that how frequently the antivirus is kicking in, like this MSP MP-eng, that's like Windows Defender. And sometimes if you keep the laptop offline for 3 days and you turn it on, you will see like the antivirus really needs to do some work, some like scanning. So that's one thing I can learn. The other thing I have learned is, well, when we use the internet browser and play a music in the YouTube, it's a different CPU usage when the Google Chrome is in the foreground, when the video is visible, or if you minimize the Google Chrome, it will save like twice as battery as normally if you would keep it like maximized in the front of you. So even if the process consumes like 1% of the CPU usage, 2% of the CPU usage, we can really learn about which processes are consuming what, and the context also is exciting. Like we can always like look Zabbix agent, how much time agent spends, and comparing with some Notepad++ or some other processes. It's like a platform to learn about stuff. All right, that is everything, and thank you very much, Monzphere, for providing this excellent masterpiece to the world. And for people out there, I highly recommend, like, if you have the money, if you have vision, like you want to solve your real life problem, don't hesitate to click the button here, contact us. You can tell like Igers sent me, this is special code to get a discount, and then like hi there, like my budget is 200-2500 euro. My goal is to have table with 5 like columns which contain like A, B, C, and then like when doing mouse over on B, show graph of like graph of C. And yeah, clear vision is important, and yeah, don't forget to mention like and using Zabbix 7.0 LTS. So you have the vision, you have the money, you have Zabbix already, and don't forget to think about the version very closely, because we have like Zabbix has a life cycle. If you ask solution for 7.2, it will end the support like after 2 months. It's not a problem if you have money, but if you think long term, maybe it's better to design solution for 7.0 LTS, because it will be suitable for few more years. So that's my recommendation. And don't forget to my email is x at but put your email there. And these guys are fast. They can create like something already. If you are worried, like is the vision clear enough, you can, if you are open to kind of like crash testing, you can say it inside this message, like I'm open to test the module. It's fine if it's not completed at the first in the first launch, and maybe we can receive a discount again. All right, that is everything for this video. This module I built during this video, I will put also not module, but this template I built in this video. I will put also a reference link on that. And thank you for watching. Give it a thumbs up, and goodbye.